Hello teachers, let's talk about chapter 4, and we get to a really fun topic. I think it's number theory. And in section 4-1 we talk about divisibility. So when we finish, we should be able to understand and explain divisibility, factors, and multiples. We're going to talk about divisibility tests for 2, 3, 4, 5, 6, 8, 9, 10, and 11. I bet some of those you know, but there's maybe some on that list that you don't know how to do divisibility tests for. And also, the set of factors is finite, and the set of multiples is infinite for any given natural number. So these are the things we want to make sure we discuss. First, we're going to start off with divisibility. Now, you remember in the last section that we talked about division, and we talked about divisibility. We're going to extend that conversation in this section. An integer is even, I know you know what an even number is, if it has a remainder of 0 when divided by 2. It is odd otherwise. So when people think of even numbers, it's 2, 4, 6, 8, 10, 12, that kind of thing. But what's common to all those numbers is if we divide by 2, the remainder is 0. On the other hand, if you take 5 and divide it by 2, the remainder is 1. So we say that 3 divides 18. Notice the notation here. This may be new to you. So 3 divides 18. That means 18 is divisible by 3 because the remainder is 0 and 18 is divided by 3. Likewise, B divides A can be written as B divides A. So this is a little bit backwards. The dividend is on the right and the divisor is on the left. So B divides A. Okay? We say that 3 does not divide 25. So notice the notation there. We just put a line through that vertical bar because the remainder is not 0 when we divide 25 by 3. For any whole number, A and B, where B is not equal to 0, we say B divides A if and only if there's a unique whole number Q such that A equals BQ. So again, A is your dividend. That's the thing you're partitioning or dividing into parts. And B is your divisor. So we can say, for instance, let me just give you an example. We know that, get this pen working properly. It's not working. We can say 4 divides 24. And the reason is we could say 24 is equal to 4 times some number Q, where Q is the quotient. Remember the division algorithm? That was A equals BQ plus R. Right here, that's the division algorithm. But because R is equal to 0 when we say B divides A, then we don't have an R there anymore. And again, what's our Q in this case? Q is 6. But if 4 divides 24, that means 24 is equal to 4 times some number. And again, that happens to be 6. Now, if B divides A, then B is a factor or a divisor of A. So we could say 4 is a factor of 24. We can also say from this same situation that 6 is a factor of 24. And A is the multiple. So 24 is what we call the multiple of 4. And 4 is the factor of 24. How do you like that? Okay, let's see if we can do an example, right? So we're supposed to classify each of the following as true or false. So does 3 divide 12? Now remember, the official way to handle this is you would say, does 12, again, I got pen issues, does 12 equal to 3 times some number Q, or whatever you want to use? And the answer would be Q is equal to 4, so you know what that means. This is a true statement. I'm just going to put T to save us a little bit of space. Does 0 divide 2? In other words, does 2 equal to 0 times some number q. And we know that is definitely not true. Why do we know that? Because you can't divide by 0. 0 doesn't divide anything. 0 is an even number. Now, what do we say about even numbers? You can divide an even number by 2 and the remainder is 0. You can divide 0 by 2, right? And the answer is 0 and the remainder is 0. So yes, it is true that 0 is an even number. 8 doesn't divide 2. You know what? That's true also. Why do we know that? Because you have 8 is equal to 2 times some whole number q. No way. You can't put anything over here but a fraction to make 8 equals 2 times something. So that is a true statement because it says 8 does not divide 2. For all whole numbers a, 1 divides a. So what are we saying? A is equal to 1 times some number q. What is that number q? A, right? For all whole numbers a. So that is a true statement. Turns out 1 divides every number. For all non-zero whole numbers a squared divides a to the 5th. What do we think about that? So here we would say a to the 5th is equal to a squared times q. Is there a whole number q that would make that work? I would argue if q is equal to a to the 3rd, that would work. Now, is a to the 3rd a whole number? It is, because a is a whole number, and if you raise a whole number to the 3rd power, you do get a whole number. So let's say that that's a true statement as well. And then the last one, 3 divides 6n for all integers n. All right, so what does that mean? That 6n is equal to 3 times some value q. They're saying an integer this time. Remember, integers could be positive or negative. Okay, so 6n is equal to 3q. What could q be to make this true? Well, if q were equal to 2n, when you say 3 times 2n is equal to 6n, and would 2n be an integer, or n is an integer? Yes, so 2n would be an integer. So I would say this is a true statement as well. Now I've got these results typed up for you. We can compare. Notice we had, look, it looks the only one that we have false is B. And the typed up version proves that we did this correct. The only problem that was false was B. All the other values were true. And I do have 2 more. All right, it says 3 does not divide 5 times 7 times 9 times 11 plus 1. 3 does not divide 5 times 7 times 9 times 11 plus 1. What do you think? Okay. All right, so does 3 divide this value? 5 times 7 times 9 times 11. And does 3 divide 1? Now, both of these would have to be true for 3 to divide the sum. I would argue that 3 does not divide 1. 3 does not divide into 1 with a 0 remainder. So that's a no-go with whole numbers. Does 3 divide this? It actually does, right? 3 divides in 9. And if 3 divides into one of these factors, that means 3 divides into the whole list of factors. So it's safe to say 3 divides the first part of the sum, that 3 does not divide the second part of the sum, which means overall this is true. So for 3 to divide what's in the parentheses here, it would have to divide both of these. And since it had the line through it, 3 does not divide that. Does that make sense? All right, so what about does 0 divide 0? Now that's kind of an unusual question. You have to think about it. When you say this number divides this number, that means we're really dividing by this number. 2 ways to think about it, okay? But I think it's safest to say this, again, this is your dividend divided by, this is your divisor, and we've already talked about dividing by 0. You are not allowed to divide by 0. You cannot have 0 divides something because you cannot divide by 0. Again, if we check our work, true, then false. How about some properties of division? For any whole number a and d, if d divides a and n is any whole number, then d divides n times a. We actually used that idea on a previous question. Let me back up. We'll leave this page a minute. Right here, when we said 3 divides 9, if it divides one of the factors, that means it divides that whole number right there. Now, we could have done this calculation, but notice I didn't. But really what I did is I used this property that we just showed you. In other words, if d is a factor of a, then d is a factor of any multiple of a. Let's continue with our properties of division, and in the previous examples, we actually used some of these. So prematurely, I know. So it says if d divides a and d divides b, then d divides the sum of them. So, for example, if I say 3 divides 6 plus 9, you know what? I know that's true because 3 divides 6 and 3 divides 9. And 3 does divide 15, right? So that's what that's saying. Notice here it says if d divides a and d does not divide b, then d does not divide the sum. When did we use that? We did. Let's back up. I'm going to flip pages on you again. Is that it? Look, that example again that I've got highlighted. 3 did divide. Let's highlight more. Do you want to? Okay. 3 did divide this part, but did not divide this part. And if it doesn't divide both of them, then it doesn't divide the sum. Okay? And you'll have some homework problems where you have to deal with that. Now, we could take a look at an example. Look at this. 4 divides, let's do 8 plus 1. We know 4 divides 8. The answer is 2. But 4 does not divide 1. And then if you went ahead and added that together, we know 4 doesn't divide 9. So it's got to divide both of them. Okay? Next one. If d divides a and d divides b, so we're back to it divides both of them, and a is bigger than b, then d also divides the difference. So another example, let's say 5 divides 25 minus 10. Right? 5 divides 25. 5 divides 10. Well, what's the difference? 15. 5 divides 15 too. Okay? So you don't necessarily have to subtract that out to actually realize it because, you know, if it divides each one, it divides the difference. But what if it doesn't divide one of them? Right here, if d doesn't divide one of them, then it doesn't divide the difference, just like example B up here with the sum. And then the last one on the list, if d does not divide a, d divides b, and a is greater than b, then d does not divide a minus b. So if it doesn't divide the second one or the first one, it's not going to divide the total. We just move that to the front one. So if you have a don't divide here, then it's not going to divide the difference either. I guess I would do you well to do an example for that, right? So let's look at 6 divides, and let's do 36 minus 15. Okay, now 6 divides 36, right, by 6. 6 does not divide 15. If we actually calculated the difference, that's saying 6 divides 36 minus 15 would give me 21. Does 6 divide 21? No. And we knew that, so 6 doesn't divide here. But the reason we knew before we subtracted is because the 6 doesn't divide the 15. Has to divide both of them. Let's classify each of the following as true or false, where x, y, and z are whole numbers. Okay, 3 divides x, and 3 divides y, then 3 divides xy. Okay, true or false. I'm going to argue that that is completely true. Now, but why? Why would that be true? Well, if 3 divides x, that means that 3 is a factor of x. You could write x as 3 times some number. If 3 divides y, then 3 is a factor of y, and you could write y as 3 times some other number. I'm just going to call it a. So does 3 divide this? Well, sure, because when you multiply this together, we know that 3 goes into that. So if 3 divides even one of those, 3 is going to divide the product. It doesn't even have to be both of them. Now, if 3 divides x plus y, then 3 divides x and 3 divides y. Do we know that's true? Let's make up an example, right? Okay. We need to make up an example where 3 divides some number over here. Well, we know 3 divides into 12, don't we? 3 divides 12. Well, what if we break down 12 into 10 plus 2? Does that mean 3 divides 10 and 3 divides 2? Absolutely not, right? So even though 3 divides the sum, we cannot split it backwards. So keep that in mind. So if you know it divides the sum, you don't know it divides each one separately. You can say if it divides each one separately, it divides the sum. We have the rule the other way, but we do not have the rule backwards. This is not an if and only if situation. Okay? If 9 does not divide A, then 3 does not divide A. So this is saying if 9 doesn't go into A, then 3 doesn't go into A. Can you think of a number that 3 goes into that 9 doesn't go into? I can. Right? How about 12? Okay. We know that 3 divides 12, but 9 does not divide 12. Now, is this a counterexample? It says if 9 does not divide A, then 3 does not divide A, and that's not true. In this case, 9 does not divide 12, but 3 does divide 12. So this is false. And if you'll remember, anytime you think something is false, find a counterexample. Find a reason, one example that makes that a false statement, and then you have proven that it's false. And if we just look at our answers, we said true, false, false. And if we look at their answers, look, true, false, false. We did it correctly. Counterexamples are the way to go. And even on the first one that was true, we wrote out an argument to show that it was true. You need to be able to do that. Sometimes it's useful to know if one number is divisible by another just by looking at it. You know, it saves a lot of time. So, for example, to check the divisibility of 1,734 by 17, you can break it up. You can break it up into 1,700 plus 34. We know that 17 divides 1,700 100 times, right? And we know that 17 divides 34 because 17 divides into 34 twice. So when you break it up like that into a sum, if it divides each part, then it divides the entire number. So 17 does divide into 1,734. Not only that, it divides into there how many times? It doesn't say how many times, right? But again, we decided that 17 divides 1,700 100 times. Now they address that 17 divides 17 and 17 divides any multiple of 17. And 1,700 or 1,700, like I was saying, is a multiple of 17. And 17 divides 34 twice, so that would be 102 times. Now we have divisibility rules. It says another method to check for divisibility is to use the integer division button on your calculator. I tried to find that on my calculator and I didn't find it, so I'm going to check other calculators. But it says press the following sequence of buttons, and you have 1,734, and it's like INT division sign. 17 equals, and it's 102 remainder 0. So look for that on your calculator. It might be helpful, but to me, the entire point of knowing divisibility rules is maybe so you don't have to use your calculator. So that's really a big goal, I think. Now, we have lots of divisibility tests. You do need to know these. I think they're great. I think you'll enjoy them too. Most of you know how to know if a number is divisible by 2. If it's even, right? And not only that, but if the units digit is even. And we like to say the ones place, right? If the units digit is even, you know the number is divisible by 2. So you can make up something crazy like 1, 2, 3, 4, 5, 6. And all you're looking at is that 6. And if that ones place or the units digit is divisible by 2, then your number is even or divisible by 2. All right, how do you know if a number is divisible by 5? Right, it ends in a 0 or a 5. You've known that for years, right? So any number that ends in a 0 or 5 is divisible by 5. So again, I could do 1, 2, 3, 4, 5. That number is divisible by 5 because you have 5 or 0 in the units digit. How do you know if a number is divisible by 10? Sure. The units digit is a 0. So I know these are not new to you, but I bet maybe before the end of the lecture I'll get to one that is new to you. How do you tell if a whole number is divisible by 4? Anybody know a trick for 4? Divisible by 4 if and only if the last 2 digits of the number are divisible by 4. So how about this one? If I give you 1,232, the reason I know that's divisible by 4 is because the last 2 digits, 32, is divisible by 4. 8 times 4 is 32, right? Then I know that entire number is divisible by 4. 8 has a very similar rule. A whole number is divisible by 8 if and only if the last 3 digits of the whole number are divisible by 8. So if I make up some wild example like 1, 5, 7, 9, and then 0, 1, 6. If you look at those last 3 digits, those are divisible by 8. 16 is divisible by 8. Therefore, this big large number, which is 1,579,016, is divisible by 8. Great, isn't it? And again, I think the value of having this is when you don't have a calculator. Because if you do, you could put divided by 8 and see if there's a decimal, and then you know that it's not divisible by that number. So let's do these without a calculator. We got an example. Determine whether 97,128 is divisible by 2, 4, and 8. So, divisible by 2. What do you think? This reads again, 2 divides 97,128 because 2 divides 8. In other words, right here, 8 is an even number. Okay? What about 4 divides 97,128? What do you think? 4, we have to look at the last 2 numbers. Does 4 divide 28? You bet it does, right? 4 times 7 is 28. And does 8 divide 9,128? Well, we need to know if 8 divides 128. Now, that's not something I know off the top of my head, so you know what I'm going to do? Our standard algorithm for long division, 8 divides into 1. It doesn't, so we do 8 divides into 12, but really we're doing 8 divides into 120. And that goes 1 time. It really goes 10 times. 1 times 8 is 8. And then we subtract to get 4, and we bring down the next number, 8. 8 divides into 48. How many times? Yep, 6 times 8 is 48. And the remainder is 0. And so because 8 divides 128, we know that 8 really does divide 97,128. It's great, isn't it? So 2 is if the units digit is even. 4, you check the last 2 numbers. 8, you check the last 3 numbers. All right, determine whether 83,026 is divisible by 2, 4, or 8. So once again, and the answers are right in front of us, We know that 2 divides 83,026. Why? Because 2 divides 6. If I change that to a 5, it wouldn't divide it. Leave it as the 6, we're good. Now, does 4 divide the last 2 digits? That's all we're checking for. No, 4 does not divide 83,026 because 4 doesn't divide 26. All right, does 8 divide 83,026? And then we would say no, 8 doesn't divide into 26, but I'm looking at the 0. So, but the 0 in the front means we're just looking at 26 this time. 8 doesn't divide 26, therefore 8 does not divide the entire 83,026. Now let's talk about sets, right? The most restrictive of these are numbers that are divisible by 8. But you know what? Every number that's divisible by 8 is also divisible by 4. So the numbers that are divisible by 8 fit inside the numbers that are divisible by 4. And the numbers that are divisible by 4 fit inside the numbers that are divisible by 2. So for example, give me a number that's divisible by 8. And I bet you're thinking, I don't know, 32. That seems to be the going rate. 32 is divisible by 8. It's also divisible by 4. It's also divisible by 2. Okay? 3 and 9 have a similar idea. So numbers that are divisible by 9 are also divisible by 3. Every number that's divisible by 9 is also divisible by 3. Why? Because 9 is divisible by 3. Now, maybe you know this rule, maybe you don't. I hope you do, though. It's great. A whole number is divisible by 3 if and only if the sum of the digits is divisible by 3. So if I just make up a random example like 1, 2, 3, 0, 1, 7, and I add those digits together, 1 plus 2 plus 3 plus 7. Oh, I forgot that 1 right there. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 7 is 13. And 13 plus 1 is 14. And since 3 doesn't divide 14, that means 3 does not divide 123,017. Okay? It's that easy. If 3 divided the sum right here, then we would know 3 divided the entire number. Hey, same thing holds for 9. If a whole number is divisible by 9, if and only if the sum of the digits of the whole number is also divisible by 9. So again, we would add all those together. We can make up a different one. So for instance, 3, 1, 2, 4. 7. Let's do that. 31,247. Is that divisible by 9? That's the question. Will I add 3 plus 1 plus 2 plus 4 plus 7? 3 plus 1 is 4. 4 plus 2 is 6. 6 plus 4 is 10. 10 plus 7 is 17, if I added that right. Does 9 divide 17? Nope, 9 does not divide 17. Therefore, 9 does not divide 31,247. We'll have more opportunities to practice those right when we come back, but I am approaching the 30-minute mark, so I'm going to go ahead and shut it down, and you'll come back for part 2. We'll do more divisibility tests. We've got 11 to show you. And I'm trying to remember if there's any other. I think we've shown you everything but 11. So we'll come back. I'll do some more examples of possibly 2, 4, 8, 3, and 9, 5, and 10. And we'll come back again and do 11. So have a great day.